Hi, everyone. Welcome to Tech Talk Tuesday. Threat hunting and trust is a really difficult combination. Today, we're going to talk through one thing on our things you trust during a threat hunt but shouldn't starter pack. These are trust relationships that often are really challenging to comprehend or cause a lot of problems with analysis. Today, we're going to talk about file certificates. There are obviously others that a lot of people think air gaps are safe, trust SSL certs, or other devices. But today we're going to focus on ways that attackers are using even signed trusted files that might evade some of your threat hunting techniques because you just assume file certificates to be accurate. So today we're going to talk, like I said, subverting binary code signing. A big modifier on here is without stealing keys. This is T1553.002, which is basically abusing code signing. We'll talk about how this modifier is different than a lot of the ways this is commonly talked about. So what is code signing subversion? Here is the link from MITRE's page. What it breaks down to is that you have executables or PowerShell scripts or other files that are often signed to try to prevent malware from running and make it difficult for attackers to get code execution. A lot of times there have been cases to where an attacker will either try to forge or steal the signing keys. We'll talk about those in a slide or two. But today we're also going to talk about ways that don't require the attacker to steal, ways that an attacker can leverage vulnerabilities and how Windows does code signing to not have to go through that step of having to steal code signing keys to get that privileged execution. So like I said, there's two ways attackers do this. So they can either traditionally, and what MITRE talks about is that create, acquire, steal the code material. If you look at SolarWinds and APT29, there's a lot of, this was one case to where the attackers stole the signing keys in the development pipeline, I believe is what's being reported on. But even wider to this is not something that just happened with SolarWinds. This happened also with APT41. This graph in the center is a number, probably a dozen or so certificates that APT41 stole throughout campaigns. And this goes all the way back to 2008 and before. So for the industrial, for the OT crowd, Stuxnet did use two, a Realtek and a J-Micron. They were able to assign binaries and other files using the stolen cert there. The other side, what we're going to focus more on today is the no key theft required. So this is leveraging vulnerabilities in the file format or how that certificate actually used. Because it turns out, it sounds like it's a lot when you have to steal that cert. Well, it's not particularly, it's not necessary for you to actually steal the cert depending on the file or to steal the signing key on that. So why should we care about this? So this whole talk and this whole topic was really inspired by this Z-Loader phishing campaign that was reported on. Here, we'll talk a little deeper into this, but this campaign heavily leveraged one of the CVs in code signing that's baked into Windows by default. So on that other side, if you look at number 2, this technique actually works by default out of the box on everything from Windows XP all the way to Windows 11. To be secure against this, organizations have to set a registry key to opt out. This sounds a little crazy. We'll talk about why. And we'll also talk about the registry key to set so you can avoid this in the defense section. So let's start with how code signing works. This right here is an example from the blog that we mentioned on the Z-Loader. They did some deeper research and they created a binary that if you look on the left, the top 2 boxes are Windows saying, yes, this is a Windows DLL and the signature looks valid. On the bottom, we dropped this P, or we found this P, this portable executable up on hybrid analysis. You'll see hybrid analysis even says this certificate is valid. It's the green box. But if you look at the hex portion of this portable executable, at the bottom, the attacker in this case, or in the research, they actually ended up adding a script that just runs a calculator there. So again, this binary in Windows's eyes is a valid signed executable and it's going to run as such, but an attacker was able to basically go around how that code signing algorithm works. How code signing works varies by the file type and operating system. So you might have differences just on, the system, or on the system architecture itself and how it handles files. It's also different by the file type. And so, how PowerShell script signatures work is going to be different than what's applied to, portable executable files and other files. So when we get into the number 2 on here, when you start talking about the subject interface package SIP, this is a part of Windows. It's not very heavily documented. In the middle, there's actually a paper. If you want to know more, check out Matt Graebner's paper. I think it's a 61-page real deep dive into Windows trust architecture. Again, it's called Subverting Trust in Windows by the Spectre Ops guys. They dive really deep into how this works and how this works across different files types. But in Windows, so there's that SIP provider, it's abstracted away, and there's 2 API calls. The when verified trustx actually calls the when verify. And this is what Windows calls when Windows is going to verify and give that green bar on there. It handles different file types. So it will go through and say, okay, is this an executable? Is this a script? Is this some other type of signed file? So that also where the forking happens, depending on the file type that you're going through. Hopping in again, because we're not going to get too far down. We want to kind of give the practical examples to help you understand. But we talked about SIP and CV 2020-1599. Here we have the script, or we have some text from the Virus Total blog. The link's below the image right there. But this is a vulnerability, and it's a vulnerability from about 2 years ago, to where the attacker again was able to add data, add a Visual Basic script in this case to the binary, and the signature chain didn't detect it. So just like we talked about in the example shown earlier, just because you have that green bar doesn't mean that there's not extra bonus material that's going to run that'll avoid that signature check. When that signature check happens, there's the assumption that, like a hash, it's going to check every byte in the file. That's not true. SIP has its own algorithm based on the type of file. And so there's ultimately slack space in the file that attackers can hide things, and it turns out execute, in this case, execute scripts in there. On the right, the interesting part is, and what brings Virus Total's blog in, is Virus Total has a really cool YARA rule they wrote on there, and they use the Graph API to actually map out different groups that are in different file samples that are using that. So definitely take a look at Virus Total's YARA rule and some of their hunting around here. It's on the blog there, but this is a CVE that it's not just theoretical what we're talking about. There's actually been cases where this has been out there. So yeah, let's look at another one now. So a little older one, CV 2013. This is a remote code execution class 1. So it's not just, hey, let's drop this extra data in and it's not going to do anything. It's actually going to run those unverified portions of the file, even with that green bar there. And this change is able to be made without invalidating that signature. This is from this text on both sides is from the Microsoft blog. The text on the right is really key to understand, especially if you're threat hunting or if you're defending a network on this. There was a time in 2013, and I think parts of late 2013, 2014, where this was turned on. But it was turned off for various reasons. We'll talk about it when we talk about the registry key. And so again, by default, even though this CVE is from 2013, it's still going to work out of the box, even all the way up through Windows 11. So if you want to be protected against this on the enterprise, you really do need to consider setting that registry key. And we'll talk about what that registry key does. So how do you defend against this? So on the network side, again, when you're threat hunting, and hopefully you're doing threat hunting to look for this, you really should be extracting out the PEs and not just checking the digital signatures. Obviously, if the digital signature is bad, you're going to want to triage that P and figure out if it's more. But even if the signature is good, you're going to want to look from Ps that you can pull off the network. You're going to want to look and say, hey, is there data in Slack space? Do I see that 2020 CV or the 2013 signs of that? You can't trust just a log that says, yes, this P is fine. You have to actually look a little closer just based on the nature of these vulnerabilities. Again, on the host side, it's the same deal, right? For the network side, you're just going to pull the file out. On the host side, you want to do the same thing. You want to look for the extra data in the file formats where it shouldn't be. You want to use that virus total rule possibly that's in the blog to look for Ps that might either be going through SSL, through other encryption, or maybe through parts of your network that you don't have visibility on. From the prevention side, and next slide, we'll talk about the registry key. But again, consider setting the registry key because what the registry key is going to do is enforce stricter verification. So let's jump to that. So on 32-bit Windows, it's just one key. It's in HKLM, you see it right there. You set that enable cert padding check to 1. And importantly, you reboot the machine. On 64-bit Windows, that first key is still there, but there's a second one. Again, you're going to add or set that enable cert padding check to 1 on both of those keys. And again, reboot the machine. What setting this to 1 does, and this is straight from the link there from Microsoft's blog or from Microsoft's certification on this. What this does is it goes through that certificate structure and it goes through some of that Slack space on the file that's not part of the digital signature, but where the data is getting injected. And it makes sure that the data in there is what it should be and that there's no non-zero data beyond certain parts of that header. So what it's doing is it's looking for extraneous data there. Now, let's talk about why Microsoft probably doesn't have this by default anymore, why they pulled it back. Is there are non-conformant executables. And so this is definitely, if you're in an industrial environment, any kind of environment where uptime matters or where, life safety or revenue safety job, you need to make sure that, if you set this registry key, that it's not going to crash a critical application on there. Definitely check it. Because like I said, application developers might have data in there that's essential for the operation of that application that turning this key on will essentially cause problems with or not allow that application to run. So again, the best defense if you're trying to prevent against this, or best recommendation if you're consulting for someone, is to say, hey, consider this registry key where at all possible and work around where you can. So again, that covered a lot of today. So thanks for joining in. Keep in touch. Our socials there, our website, we're open to ideas. And yeah, thanks a lot.